Hello, lovies. This is the second part of lesson 84. In this video, I'm really hoping to clear up any confusion that there might be about complex sampling methods. So we have talked about three simple random samples, three ways, the easiest ways to take a random sample. That was with an SRS, or I guess I should say that is an SRS. And the three methods that we talked about were hat method, using technology, and random digits. In the last video, we talked about the complex sample methods, and these, or I shouldn't say sample methods, sampling methods, these are the best methods, and often these include using an SRS. So a systematic sample does not, and a systematic sample is not an SRS. But taking a stratified sample or a cluster sample does have an element of taking an SRS. So on the next page, if you got your notes from me, I have taped at the top this little paper. So I'm actually going to take it off so that I can label it and move it around as we work through this problem. That took me like 10 years because I was trying not to ruin my paper. So we're going to pretend, or we're going to set this up so that this looks like a school auditorium. So this is a school auditorium, and you can think about it as the auditorium at Cypress if you'd prefer. This is your stage, and then based on that we have 4 rows and 3 sections. So in relation to the stage, we have 4 rows, so this would be row 1, row 2, row 3, row 4. And then we have 3 separate sections. Section 1, Section 2, Section 3. So back at Matheson, when I taught at Matheson, we had a seating chart for assemblies, and we were required to take our classes down and sit in a specific seating chart. So maybe you remember that from junior high. In this case, we're going to set this up as if we have some kind of required seating or some way to have our kids sit. So in this particular case, we are going to have all of our 9th graders sit in the front row. 10th graders will sit in the second, then 11th graders, then 12th graders. So all of our 9th graders are sitting on this row. 10th, 11th, 12th. We are going to walk through taking a random sample of 20 students from the auditorium. So we're going to take a sample of 20 of these students. The simplest way to do it would be to take an SRS. So this is hat method, calculator, or random digits. Step number 1, we label each seat with a unique or a distinct integer. From 1 to 60. Now, I know that it's going to be 60 because I've done this problem before. We would have otherwise needed to count these up and then write in what our numbering was. So I'm going to start here and call this seat 1, and then I'm going to move to the right. So I'm numbering these from left to right, which means that my first row is the integers 1 through 15. So I'm going to carry on with the second row. and I end with my seniors. And I did number up to 60. So there are 60 kids sitting in our auditorium right now. We are taking a simple random sample of 20. I'm going to use my favorite simple random sampling method, so I'm going to use hat method. I'm going to write the numbers on identical slips of paper and put them in a hat. I am going to shake the hat to randomize. So remember, for a simple random sample, it's always label, randomize, select. Label, randomize, now we select. Pull slips out of the hat one at a time until you have 20 seats, then stop. The students sitting in the seats that correspond to the numbers you pulled out of the hat are now our sample. So let's briefly talk about advantages, disadvantage. So for the SRS, an advantage would be that it's easy. It's simple. It's a simple random sample. The disadvantage is that we cannot guarantee fair representation of the grade levels. So when we take this simple random sample, because each student has the same chance of being chosen, I could end up with like 10 12th graders, 5 11th graders, 2 10th graders, and 3 9th graders. If I take a simple random sample, I have no control over the amount of kids I get from each grade level. And that might make a difference depending on what I'm taking this sample for. If I am taking this sample to find the proportion of students who want to continue distance learning next year on Fridays, I'm not going to want a bunch of 12th graders because the 12th graders are not going to care either way. So I want to make sure, or it may be better, I guess I should say, if I was able to determine how many from each grade I could pull. If I was taking a sample to figure out the proportion of students that were satisfied with our parking, and I ended up getting a majority of 9th graders, this sample would not represent the population well. So the advantage with an SRS is that it's easy. The disadvantage is that you cannot ensure equal representation. And especially in this case, that matters. So by equal representation, I mean equal representation amongst the grade levels. I could end up with the majority of one grade. So cannot ensure equal representation. Okay, selecting a systematic sample. Now remember, this is not an SRS, because once we choose that first student, after that, it's only every nth student that could be in my sample. So it starts the same. Label each seat with a unique number or a unique integer from 1 to 60. I will use my calculator to randomly generate a number, a starting number. So when it says randomly generate one number, this is your starting number. What you're doing here is an SRS. So when I first started this video, I said these complex methods, they do involve an element of taking an SRS. So even though this is not an SRS, we do use an SRS to get started. Well, how do I know what number I need to generate? Because I have 60 students sitting here. So how do I know where I should start? Well, the best way to figure this out is to take your population size, so 60, and divide it by the size of the sample that you would like. So we're going to divide it by 20. That is going to give you 3. That means that you want to randomly generate a number between 1 and 3. So if I were using my calculator to do that, and I'm not even sure that I have a calculator by me right now. I bet you I didn't bring one home. Oh, I'll just use random.org. If I can remember how to get out of here. Okay, so I'm going to just go to random.org. And then over here, my min is 1, my max is 3. I'm going to generate one number, and that's 1. Thank you. So I'm going to start with student 1. So in these seats, so many buttons. In these seats, this person sitting in the first seat is the first student in my sample. And then I'm going to choose every third student from there. So I use my calculator to randomly generate one number between 1 and 3. How do I choose this range? Well, I divide my population by my sample, and I use this number as my guide. So starting at the seat number my calculator generated, so I got 1, my sample will be the student sitting in that seat number, and then every third student after that. Where am I getting this third student business? Capital N divided by N. I am going to highlight now my sample then. So my systematic sample is going to be student 1, and I got that by taking a simple random sample, and then I'm going to go every third after that. So 1, 2, 3. So I'm highlighting the third person. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. And now I'm kind of seeing a pattern of how I'm going to highlight. So there is my systematic sample. I started at 1, and I chose every third person from there. The interesting thing about this systematic sample, especially if you set it up right by doing capital N divided by little n, you end up getting fair representation between the grade levels. So you can see now each grade level has 5 people being pulled into the sample. So a systematic sample is a good method for selecting a sample. You have to keep in mind, though, that it's not a simple random sample. It's a complex sampling method. Then the last two are the ones that that I think people struggle with the most. So next up would be selecting a stratified sample. So remember, we often go with a stratified sample because we want to ensure equal representation of the grade levels. So a stratified sample is going to ensure equal representation of grade levels. So remember, a simple random sample, you could end up with a bunch of 9th graders in your sample. And if you're sampling about the parking, not a great idea. But with a stratified sample, we can ensure that the same amount of kids from each grade level get pulled into our sample. Starts the same as all the others. You're going to label each seat with a unique integer from 1 to 60. Now, it's really important when you do a strata or a cluster that you explicitly define what your strata are. So I will use grade level, which in our case is the rows, as your strata. So here I'm going to label these according to that. The first row would be considered strata 1. Second row is strata 2. Third row is strata 3. And fourth row is strata 4. So we have 4 stratum. So I think that I will highlight this as well, just so that if I refer back to this picture, I know what I was doing. So I have 4 strata, and each strata is a grade level. Now this goes back to the idea that in each strata, the members are similar or share a characteristic. So in strata 1, they're all 9th graders. In strata 2, they're all 10th graders. If I only sample from one strata, it does not represent the population. It only represents the population if I take members from each strata and combine them. So that's what's happening here in our rows. So now I have to describe how I'm going to take members from each row. This is going to be an SRS. So we're going to explicitly state that the freshmen are numbers 1 through 15. The sophomores are seat numbers 16 through 30. Juniors are 31 through 45. And seniors are 46 through 60. For my first strata, I will use my calculator to randomly generate 5 unique or distinct students from the freshman row, which is strata 1. How do I know that I'm going to take 5 from each grade level? Well, my sample size is 20, and I have 4 strata, so that's going to make it so that I have to take 5 from each group. So 20 is my sample size. 4 is my number of strata. Divide sample size by number of strata, and that tells you how many to take from each group. So if I'm using my calculator, uh-oh, this one's different. I don't know how to use this one. So I would have to go back onto random.org and generate 5 distinct numbers. Okay, so I would take 5 from the 9th graders, and then notice instead of describing that same thing for the sophomore, junior, and seniors, I just say I will repeat the process for the rest of the stratum. So for the sophomores, the juniors, and the seniors. The only thing that will change is that when you find numbers for the freshman row, your minimum would be 1 and your maximum would be 15. And then you would hit generate as many times as it takes to get 5 unique seat numbers. Then you do 16 as your minimum for the sophomores, 30 as your max, and then you hit generate until you have 5 unique numbers. Same for strata 3 and strata 4. So you adjust your minimum and your maximum, but the process is the same. This is the element that is an SRS. I'm going to just show you very quickly what that looks like for the seniors, because I want to make sure that we're all on the same page. So for the seniors, my minimum would be 46, my max would be 60. I hit generate. My first student that I would pull is 48, 59, 56, 46, 55. That's interesting. We have 2 people that were in the systematic sample and the stratified sample. So the 5 seniors that I would pull based off of generating random integers would be 46, 48, 55, 56, 59. And then I would do that for the other 3 strata. I'm not doing it for the other 3 because then our paper is going to look really crazy and this will take 2 days, and I'm trying not to make this video 2 days long. So, okay, once I have generated 20 unique, I lied. Once I have generated, yeah, I think that was 20. 20 unique students from each row, I will stop. So once I do that for each strata, I stop. No, is that supposed to be 5? Once I have generated, oh yeah, it's 5. 5 unique students from each row, I will stop. Because 5 unique students from each row adds up to 20. Got it. Combine the 5 unique students that were randomly selected from each row. These 20 students are my stratified sample. So a couple of important elements in this section are, you have to say that you're combining the members of the population that you took from each strata. If you don't say that you combine them, you won't get full credit. So 1, you have to say that you are going to combine those samples into one bigger sample, and then that represents the population. Okay, our last one is our cluster sample. So an SRS is we just essentially put the numbers 1 through 60 in a hat, shaky, shaky, shake, pull out 20. Disadvantage, we could have a misrepresentation of each grade level. So we could end up with a majority of one grade level. Systematic sample, we randomly choose our starting student and then choose every nth person after that. Stratify, we break or divide our population into groups that look like each other. So in this case, it was grade level, and we take the same amount of students from each grade level. That's the best sampling because it ensures that you have equal representation. And then last is the cluster sample. Remember, the advantage to the cluster sample is that it saves time and it's easier than stratified. So faster and easier compared to a stratified sample. So there are 3 sections in the auditorium. We're going to label them left, middle, right. Those are our clusters. So this would be your left. That's cluster 1. Middle, that's cluster 2. And right would be cluster 3. Notice that within each cluster, you have every grade level. So if I just take one section from the auditorium, it does look like the population. It includes 9, 10, 11, 12. Compare that with a strata. One strata is all one grade level. One cluster includes every grade level, so it does represent the population. I will use the sections as my clusters. So notice in the stratified, I had to explicitly say I will use grade level as my strata. Here I'm explicitly saying I will use the sections as my clusters. I will write the name of each section on identical slips of paper and put them in a hat. So once again, this complex method includes an element of an SRS. I will shake the hat to randomize and pull out one slip. My cluster sample is all the students sitting in the section that is written on the slip I pulled out. So I did this. I actually put the names in a hat and drew them out in a different class. So when I did that, I don't know what color I want to highlight with, family. Do you guys ever have these issues that you want everything to look nice together, so you don't know what to highlight with? I'm just going to go with this one. When I have done this previously, what I got, why do these both say cluster 3? What I ended up pulling out was cluster 2. So I pulled out a slip that said middle. So that's my cluster sample. The keyword here, so in Stratify, your keywords are that you take from each strata and then combine. So stratified, take from each strata, combine. For a cluster, you take a cluster and sample every person or all the members of that cluster. So the key word here is the word all. So if it ever says you're going to ask every person or include all people, that's an indication that you're dealing with a cluster. So now I'm going to tape this back on so that I have it for my reference. I am hoping that giving you the specific bullet points for each sample and having this auditorium visual helps you understand the difference between a simple random sample and our complex sampling methods. It's also important that we understand that an SRS is not necessarily the best method because we could have the majority of one kind of thing in our sample, and that can lead to bias. Systematic is not an SRS. Stratified has a statistical advantage. It ensures equal representation. Cluster has a logistical advantage. It's faster and easier than stratified. So that's the one last thing that I want to mention. For your systematic or your strata, you have to go down each row and get all of these kids, which could take some time. But if all you had to do was survey that middle section instead of having to go around to all the kids in every section, that may end up saving you some time and be a little bit easier in the end. That's why a cluster sample saves time and money. And when you're talking about neighborhoods as your cluster, then you really start to save time and money. And when I say neighborhoods, I mean your literal neighborhood, like houses that are by each other. So if you have any questions, make sure you let me know. If you're watching this in real time or close to when you're supposed to be doing this lesson, I'll be in my classroom for the rest of the week, the majority of the time, so stop by anytime that works for you if you have questions. Next up, you are going to finish your check for understanding. So it's page 817 to 820, and I will make sure that I get the solutions up for this as soon as possible. Okay, that's it. Love you guys.